So, my talk is about our story at Zalando mostly. So you can see from where we came, why we wanted to change things, how we approached this from a cultural and organizational aspect, and what that meant in the end for our tech landscape. We will also cover a couple of the challenges we encountered there. And if we have still time, I can also show you a little bit about what we did with the online shop, because microservices as a concept applied to front end is a different type of challenge, and it's not that easy to solve. So that's me. It's incidentally, I have also the same shirt here. It's, I don't know, it's not by choice. I wash it sometimes. Okay, let's start with Zalando. So who of you doesn't know Zalando? Okay, at least a few. In the States, for example, we are virtually unknown, which is interesting because we're really, really huge. And this is our vision. So what we really want to do is we want to connect people with fashion through a couple of different channels. We want to connect, for example, a stylist with a consumer and also with a supplier. And of course, we want to sell fashion in the end. We're really huge. I don't know if any of you have an idea of what scale we are right now. We have 15 countries with around 18 million active customers who buy stuff during the recent months. And last year, we made around 3 billion revenue. We were at one point the fastest European company to reach 1 billion revenue, so it grew really quick. And right now we have around 10,000 employees, and we're reaching 1,200 in tech alone. We have 7 tech hubs all over Europe, so the biggest ones are the ones in Berlin, the one in Dublin, and the one in Helsinki, but we also have smaller ones in Germany. Yeah, let's go to the early days. So Zalando was started in 2008. The proof of concept was made with Magento as the basis to see if selling shoes online is, feasible. Because a lot of people at that time thought, selling shoes online, what if it doesn't fit? And so there were a lot of concerns. It was like a crazy idea. And the Magento platform allowed the business to try it out and see how it goes. Magento is an open source shop solution. There's also an enterprise one, and it's based on PHP. So we did that, and we grew pretty quick. So people really liked to buy their shoes online, also because we had this free return policy there. And very soon, we came to a point where the load on the system couldn't be handled anymore by that particular e-commerce system. So we had to build a new system, and we had to build it fast because we were already at a point it just couldn't go any further. We consulted with the CTO of Magento. We did any kind of tuning possible to the system. It just couldn't take it, right? So we spent approximately 3 months on building our own e-commerce system based on Java and Postgres. And now we had an interesting situation. I guess many of you have seen that before. So if you go through a time where you have a lot of issues in operations, right? You have a lot of load issues, systems can be down and stuff like that, then you tend to get a little bit on the defensive side of things. So when you design your next system, you tend to be very careful that it really can handle the load, that it's rock solid and stable and everything, and you try to sort of take precautions. And what we did then was we pushed a lot of the business logic into the database layer, so a lot of that was done in stored procedures in Postgres. And there was a lot of business logic, right? Not just 2 or 3 sort of procedures. There were like hundreds. And as you can imagine, maintaining that sort of code base gets tricky, right? Yeah, so by the way, does anybody of you know this painting by chance? Yeah, right. It's also the loading screen of Civilization 5. But yeah, it's the Tower of Babel. And the Tower of Babel is also interesting because the people at that time, so the story says, could only build this because they spoke the same language, right? And that's also something which monoliths tend to have as sort of a restriction. So basically, everything you build needs to be in the same language. Otherwise, yeah, it's not a monolith anymore. And we had that situation, so we had this language lock-in here. And yeah, after we built this first e-commerce system, we started to add features on top and on top and on top for 5 years. So every country obviously has their local specialities, like let's say payment or delivery. Or we also did a lot on the logistics side of things. So the systems grew. So at that point, we didn't have really one monolith. It's like a simplification here. We had a couple of them, but they were really big systems. So what does that mean? When we look at the productivity of our teams, we have a lot of teams working on the same code base, which is quite huge. So you have a lot of dependencies. If you want to do something, you have to check what are the others doing. Are you impacting their code in any way? Are you impacting the operations of the system? You need a lot of coordination around the teams to do that, also with releases, for example, and QA. And this leads to this law of diminishing returns, which means that adding more people, right, just doesn't bring a lot of extra value, because the more people you have, the more dependencies you create, and everything slows down. You can reach a point where adding people is detrimental, where you're basically slower than before. And this is not a really good situation to be in. And we also saw that innovation suffered. So to stay on top in a tech environment, you need to be very innovative. You need to bring out new features. You have to reinvent yourself. And with a huge code base, you have the problem that the bug density just increases with the lines of code. There are certain studies around this. And you also see a lot more side effects. So if somebody changes code here, it can break something elsewhere. And it's very hard to contain this. So what people tend to do, or companies tend to do in this situation, is that they create rigid processes around the whole software development cycle, like QA processes, like webhooks into your version control, into your ticketing, to check everything, right? Like checks you do in your deployment application, for example, to really boil things down to a controllable state, and to sort of kill any kind of variance you might have in your software development process. And if you kill variance, of course, you also limit your innovation, because, I mean, innovation is variance, right? You try to bring something new. So we had less innovation here. Good example is this programming language lock-in we had with Java. So we couldn't deploy anything else. So if you wanted to go for a Go application or something, bad luck. Huh? Not very nice. And we also saw a bad impact on growth. So growth from the people side of things. Of course, we want to grow there. We want to have more engineers. We want to bring out more products. And if you have a huge code base, one aspect you see is that new starters have a really hard time to get confident with the code, because it's so big. They have to learn so much, and they really also don't want to take any risks there. It's pretty hard, because they can't understand everything. So this is quite bad. It takes months for somebody to really be productive. And, of course, Another thing which, yeah, as the tech crowd, you know, we tend to like new technologies, right? And we tend to play around with something new, to experiment. But if you're locked in an old tech stack, which is basically 10 years old, because in 2010, when we decided for this Java Postgres stack, we decided for something which was proven and stable, right? So it was around for quite some time. But the younger engineers, which come up from the universities, yeah, they're used to other technologies, to newer ones. And if they get onboarded into a company which just doesn't provide that environment, they're demotivated. So in fact, what we saw was that our company for tech was not very magnetic. People didn't really see us as a tech company. And when they heard about what we're using, right, this was like a point where many of them just decided not to join Zalando at that point. So hiring was pretty slow here. So we had to change something. If we wanted to still be on top in the retail space, in the fashion space here, then we needed to do something. So then we sat together for a couple of months, like around 30 people from tech, and thought about how do we have to restructure our organization and our culture to improve on all of these things, to create an environment which engineers love, right? We called it radical agility, and that's basically what we wanted to have. We wanted to have autonomous teams which could deliver new products efficiently at scale, which means like we wanted to take a couple of engineers, put them in a speedboat, and then tell them which direction they should go, and then leave them and see what comes out of it. And there was, yeah, quite a break from the former culture at Zalando, which was due to these rigid processes, and the history we had was a lot more controlling. So that's what we did then. We draw this comic strip here. And if you've read the book Drive by Daniel Pink, then this might be a little bit familiar because it served as an inspiration. So we have 3 principles here. One is purpose. Purpose means everybody wants to know why he's doing what he's doing. And that means that the teams can define with their product owner, they can define their own purpose inside the company. So what is it? What is it that they want to achieve? This serves as quite a motivational boost here. There's not only the team purpose, there's also the individual purpose. Everybody has some sort of purpose. Maybe you want to be the best DevOps guru in the world, or you want to be a highly skilled expert at Scala. This is something we also see, and we also try to help our engineers achieve that purpose and, yeah, go further there. And of course, we have the company purpose, which gives some sort of direction, what we want to achieve in the mid and long term. Right? So autonomy, the second principle, is a very important one and also quite hard to achieve. Autonomy means basically that people are free to choose how they solve things. So in the book, so in theory, it's comprised of 4 T's. It's team, technique, time, and fourth one. Okay, forgot that one. Anyway, it's about having the ability to really define how you want to work. And that also means that the teams can choose the technology they think is best for their current task at hand. They can decide how they want to structure their time, right? When to do meetings and stuff. So we try to leave them alone there. They can decide how to prioritize their tasks based on their own purpose. So if they define their purpose, if they build up some, let's say, product KPIs to track how they're going, they can just look at that and think about how can we improve our own KPIs to get better at our purpose. And we have a mastery as the third principle here. Mastery is about our drive to get better at what we do. Everybody wants to do a good job, right? There's probably nobody who really wants to do a crappy job. And this mastery aspect is something which is often overlooked in most tech organizations because usually tech leadership has two responsibilities. One is delivery. The other is people development. And when it comes to deadlines, people development is mostly pushed to the side. So it has not the same amount of effort put into it than delivery. That's also why we changed our leadership structure here to allow 100% focus also on people development. Everything together is held by trust. Obviously, if you give people autonomy, you have to trust them to do the right thing. And this also means quite a mindset change from a leadership perspective, because you really have to step back sometimes and just have the team do what it thinks is best. And a lot of people are, for a lot of people, this is difficult sometimes. If you have the opinion that this is a wrong direction, you can, as a tech lead, you have to convince the team with arguments, not with your role in the organization. I think that's a very good move. So, yeah, goals here also increase innovation and productivity. Let's look at Conway's Law. So we changed the organization based on this philosophy. And if you change the organization, as Conway puts it, you also have to change your tech landscape. Otherwise, you get some sort of friction. It just doesn't fit. Right now, we're in the middle of it. I mean, organizational changes also take some time, but changing the complete tech landscape of a big company like Zalando takes even longer. In the middle of that, teams still have to cope with older systems, which, yeah, let's say cover more than one team, while building their new systems, which cover only one team. So, radical agility is not only the organizational idea and the culture idea, which we had, it's this and the technology landscape, which fits to that idea. So here I have from Adrian Cockcroft a nice quote regarding what a microservice is. And I tried to create a sentence which describes our organization, and yeah, it sort of fits, right? That's the idea here. So creating an architecture which fits to the organization. Okay, let's go to the challenges we had. There are a couple of them. Operations. Operations is a pretty important one. I recently read a Twitter blog which said that they spend, I don't know, hundreds of staff years just reaching, again, operability of their systems after switching to microservices. We have also Martin Fowler, who said that there are 3 prerequisites to microservices, by which he means you shouldn't do it if you don't care about these 3 things. So rapid provisioning, rapid application deployment, and basic monitoring, which are all a lot harder in a microservice environment where you have hundreds or thousands of microservices. We've heard today a couple of talks, especially about rapid provisioning. And yeah, we did our own solution there. And monitoring, especially if you want to track, let's say, a call from a customer over dozens of different microservices, is also kind of tricky. You cannot really do it if you try to log into a server and tail the logs. It's a little bit more complex here. So that's our operational setup. We use for provisioning AWS, also because of its huge ecosystem. We use Docker as the deployment technology, and for monitoring we go with AppDynamics and with Zmon2, which is a system we build ourselves. It's also open source if you're interested. I like it because it's quite good for, let's say, more business-oriented metrics and KPIs. And we use Stups.io, which is our framework for Docker-based applications on top of AWS. You can have a look at Stups.io. They have a website, and it explains how we solved that. It's not really, you cannot really take it and use it for yourself because it has some very customized points in it. So, yeah, but you probably can get some ideas out of it. Stups.io does the following. So we have Docker deploy. We have SSH access to machines. We have audit reports, which is pretty important for us because we are a public company. We need to comply to certain things. And we can give teams full AWS access. So every team has its own AWS account and can run there whatever they need to run. Mindset. Mindset is also very important. It's on the engineering side, but also on the leadership side. So we have here a change when it comes to looking at the availability of services. So if you design a new microservice, and this one is dependent on others in a way, then you really have to expect that the other services can fail, because they will at one point in time. You have to try to build your system in a way that it's resilient, that it can cope with failure. And there are multiple things you could do. For example, you could try to do mostly asynchronous communication between the systems. You could try to use historics. You need to think about service degradation, for example. So what can I offer to the customer if that particular service is down? Can they still do something or not? How can I try to keep things stable, right? Then we have end-to-end responsibility. This was a big thing because before that change, teams were just developing new software, and then it was like thrown over to QA, and they will fix it, or they will see what's wrong with it. So we changed that, and after QA, by the way, it went to sort of a platform team, which covered the whole operations. We changed that and moved that all to the team itself. So the team itself is responsible not only for developing, but also for testing, and also for operating what they build. This is a bit tricky because you need certain skills for some of these things, and so we really have to also train the people and give them the necessary tools to achieve that. Software as a service is something of a guideline. So what we really wanted to have is that teams also feel a little bit like they're a small startup, because they have this responsibility, and they should think about what they build as you would if you would create a software as a service company. So have excellent APIs, have good documentation, be stable, have SLAs, right? Build your system in such a way that you could theoretically offer it as a product somewhere. And we had API first, which is a new approach we took. So if you're a team and you want to build a new service, let's say a stock service, right? Then your first thing would be to create the API. And this API would then also be reviewed and checked by a dedicated group of engineers. What we wanted to make sure here is that the APIs are, correct in a also semantic way, right? We also created one interesting tool called Play Swagger, which allows you to write your Swagger API and create the play code for that automatically. It's open source also. Global architecture, that's also a very interesting one, because if you have a lot of teams and everybody does what he thinks is best to solve their particular concern, then it gets hard to have a big picture of your architecture. And what we also didn't want to have is some sort of ivory tower software architect sitting somewhere and designing some great tech landscape there. So how did we try to do it? So for one, we introduced peer review. For example, the API Guild is one, where we try to give advice to the teams regarding their architecture. We try to get a shared concept of the business entities into the team. For example, a brand, right? If we look at a brand, what is a brand? A brand can be something attached to a shoe, but it can also be an organization which acts as some sort of user for one of our systems. So these sort of things have to be handled. We created Tech Radar, which is a list of technologies we think are worth experimenting with, or which are safe, or which are unsafe. So we rate them. We won't tell a team not to use something if they have a very good reason for that. If you want to build, for example, an augmented reality app for the warehouse and you just have to use .NET for that, okay, right? You can. And we created a rules of play document, which covers a lot of these topics, how microservices should be built, the whole resilience part, the sizing of a microservice, which is always a big question. And yeah, you can have a look. We have it on GitHub, in fact, this one. So another big topic here is compliance and security. So as a publicly listed company, we have to take a look at that. We have to have a 4 eyes principle there, and we have to still keep it after teams are autonomous. We have to guarantee audit trails. If something bad happens, we need to prove how that came to be. Identity and access management, a very big topic and very difficult. So we tried to move to a completely new identity and access management in that time. We wanted service-to-service authentication. We wanted customer-to-service authentication. We wanted authentication for external services through APIs. We tried to solve it all with one go. We didn't make it. We switched back to our own solution based on JOT tokens, at least for the customer side. Yeah, I mean, here you have to see that in the microservice world, there are a lot of authentications going on. When you do one call to, let's say, one page, this might trigger 20 calls to some web microservices. These might, in turn, also trigger other calls. So you have a lot of stuff. And we heard this morning that latency there is also a point. So you want to reduce that. Data protection is, in Europe at least, a very important topic. Many companies, especially bigger enterprises, don't trust Amazon so much, so they want to be on the safe side here. We took, I think, around 3 months to get a data protection agreement with Amazon to be able to deploy our applications there. So we have, I think, a little bit of time still for the case study of the fashion store. The fashion store is also quite monolithic, at least it was, and one of the missions we had last year was to rebuild it. And we tried to take the concept of microservices and apply it to the front-end world, which is, a little bit different because everything is one page in the user browsers in the end. So what did we do? So we created a structure where teams own fragments of a page. If you look at a page, let's say a catalog page at Zalando, you see multiple parts of it, like the header, for example, or the navigation, or the catalog itself, and the footer, and all of these are their own fragments. These fragments are served by web applications owned by each team. So they serve the complete markup there for this fragment. These web applications, in turn, can call microservices. They can have their own data storage. Then we have this nice layout service over there. This layout service knows how a page should look like, so it knows the layout through the template and the context. And then tries to call all of these endpoints for the fragments it needs to build up this page asynchronously. We borrowed a bit from Facebook's big pipe concept there and tried to implement that. On top of that, we have the router. The router is an application which first allows us to route calls either to the old shop application or to the new one. And we can also do, let's say, small test runs here. So we could say, for example, we want people in Italy to go to the new part of the page, but only 5% of them. And we can then test that against the old setup and see if anything is wrong or not. The router is written in Go, by the way. The layout service is in its current incarnation Node. And we did these things as open source, so you can have a look there. There will be also a bigger blog post in the near future around Tailor, so the layout service, and how we do the streaming of all these fragments to the client. So, result, we can inject new features at runtime into the shop, which was not really possible before. We have faster feedback loops because each team can adapt to its own speed here. They don't really need to wait on other teams to deploy something. It's tag agnostic. You can build your own fragment the way you want, more or less. There is some implication here regarding UI. We are more productive with end-to-end responsibility, with a full control, with lean agile processes, which every team can define on itself. We have independent development, continuous delivery is possible in that way. Faster onboarding, more magnetic, and yeah, we can just add new teams as we go. So, here are some links. You can see it in the slides later. I don't know, do we have still some time, or do you want to go to questions? 2 more minutes. Okay, an interesting part in the front end is also the look and feel. So usually when you look at standard web pages, there is some big CSS file, right? And this defines everything. So how do you really make that work with these autonomous teams? So CSS is also not really a programming language in that sense. So you can easily override other people's CSS styles, and then your page can look quite crappy. So there are certain best practices you can do there. But also you have to keep in mind, what if you want to have a redesign of your page? Would you then, as your UX team or your UI team, have to go to every team and ask them, please, please, apply my new CSS guidelines, and then deploy them? It would lead to a situation where you would have a system which is inconsistent, which would have the new button type on some pages and the old one on the others. It's a situation you don't really want to have. That's why we saw a lot about this and tried to come up with a solution where we can inject UI changes centrally. They would be applied to all fragments which we serve immediately. We do that in Tailor, and it's a UI component library. We are not there yet. Right now, it's more or less a technical concept or experiment stage. We will develop that pretty soon and bring that live. And one thing I want to note here is this architecture is live right now. So we built that up while moving to AWS with the checkout. And if you're in Italy or in Poland, you would go to the new checkout, at least on your mobile phone. So it works. We didn't have any big incidents there. If you're interested, just write me a mail or something, and I can connect you with our engineers who came up with that. So, please remember to rate this session. This is also something about this mastery aspect. Of course, I want to get better, so it would be nice to get some feedback here. And if you want, we can do some questions.
So the majority of the questions were actually about how to convince middle management to convert from a monolith to microservices. What would you suggest there?
We didn't have that problem, in fact, because most middle management, especially in tech, are also people who are interested in new technologies and new approaches to technology, so they were behind that. I think the more difficult part was to convince them to give up control and to give autonomy to the teams. That was the tricky part.
Okay. There's a question about the autonomy of the teams and how you internally communicate available services within the organization. So if you have lots of small groups of people defining lots of small services, how do you let them know about each other?
Yeah, it's a good question, a fair one, because if you have autonomous teams, they tend to isolate themselves a little bit because they don't need to speak to everyone, right? So there are some teams which just do their own stuff, and that's kind of bad. So what you need to do as an organization is you need to create new communication channels for the teams to get together and to talk about what they're doing. And also with regards to new services, if a team is building a new service, in the end, if no other teams are using it, it's of no value to the company, right? So adoption rate of new services, especially internal ones, is a KPI which we use to measure how successful that team is.
How do you measure that? Is that automatic or is
No, it's not automatic, but we can, for example, if we build a new continuous delivery service, right, for other teams, then you can count the number of teams using it as a KPI.
Okay, good. So there's also a question here. How large are your teams in general?
We follow this 2 pizza rule, so we try to be around between 2 to 12 people, where I would say the best size is 6, sorry for that, 6 to 7 people, yeah.
Okay. What kind of microservices architecture are you using? Are you using a synchronous calls or are you using asynchronous calls?
Depends on the team, in fact. So we try to go asynchronous as much as we can, but if it's not possible, we try to use Hystrix.
And the last question here is, do you feel that your approach at doing microservices on the front end has been a success, or is it getting there? What's your current gut feeling?
I think that the basic architecture is a success because it runs and doesn't have a lot of problems. But only at the beginning of moving everything there. So, as I said, it's just a checkout by now. Other teams are currently ramping up their migration to this new architecture. One thing which is an issue there is that we're not only rebuilding the shop, we're rebuilding everything. So the entire backend services, everything, from article services to stock to payment, everything. So we're trying to build something on top of a moving platform right now, which makes things a bit complicated.
Okay, thank you.
Thanks.
Give him a hand.